Morning. I am Riji, Associate Professor, Department of ECE. Today we are going to see about communication protocols in unit number 4. On completion of this topic, students can understand the basics of communication protocol. What is communication? Communication is a terminology which involves exchange of information between two media. In embedded system, communication means exchanging of data between two microcontroller in the form of bit. This exchange of data bit in microcontroller is done by some set of defined rules known as communication protocol. If the data is sent in series one after the other, then the communication is called serial communication protocol. Here you can see two types of communication protocol: serial communication protocol, parallel communication protocol. Serial communication protocol CAN, Ethernet, I2C, SPI, etc. Parallel or ISA, ATA, SCSI, PCA, IEEE 408. The diagram shows how the data is transferred one after other in serial communication. Parallel communication is possible. In transmission mode, there are classified into simplex, duplex, half duplex. In simplex method of media, a sender or receiver can act as the time. So if a sender can transmitting the data and the receiver can accept and vice versa. So simplest method is one-way communication technique. The well-known example is television and radio. Half duplex. In half duplex mode, sender and receiver can be active but not at the same time. So sender is transmitting the information and receiver is get the information and vice versa. This is internet where the user can send a request from data and get it from the server. Full duplex. In full duplex, both the transmitter and receiver data at the same time. This is used in mobile phone. Clock synchronization. The clock is different for serial data and classified into two: synchronous serial interface and asynchronous serial interface. Synchronous serial interface, it is a point connection from a master to slave. In this type of interface, all the devices use single CPU to share the data and clock. The data transmission become faster to share clock and data. Also, there is a no mismatch in baud rate. The well-known examples are I2P and SPI. Asynchronous serial interface. In asynchronous serial interface, the external clock signal is absent. So, in asynchronous serial interface can be used most in long distance application and perfect for stable communication as shown in diagram. In asynchronous serial interface, the absence of external clock source make it rely on several parameters for controlling baud rate and transmission control. The well-known example of RSA, baud rate. Baud rate is a rate at which data is transformed between the transmitter and receiver in the forms of bits per second. So the most commonly used baud rate is 9600, but on the selection of baud rate 1000, 1200, 2400, 4800, 57,600, 11,000, 1 lakh, 15,200. The baud rate will be fast, data is transferred at a time. Also for data communication, baud rate has to be same for both transmitter and receiver. Synchronous serial interface, SPI protocol. SPI protocol is a synchronous interface which allow SPI microcontroller to be connected. In SPI, separate wireless are required to data clock. Also, the clock is not included in the data stream but furnished a separate signal. The four basic SPI signals are MISO, MOSI, SAK and VSS, ground and part of data communication. So it needs 6 wire to send and receive data from the master and slave. The data communication is constant in SPI register. The SPI can deliver 10 Mbps of speed and is ideal for high speed data transmission. This is the way how it will. One master and slave. So it consists of 6 pins, VCC and ground apart from those pins. Master in slave out master in SCCA, etc. This is a synchronous serial communication. I2C, integrated circuit, is a two-line communication between IC and module, where two lines are SDA and SCL. Both the lines are connected in positive supply or pull-up register. I2C can deliver 400 kbps and using 10-bit or 7-bit addressing system to target specific device on I2C, but it connected to 1014 device. Same as SPI, microcontroller generally have I2 pin to connect any I2 device. So you can see here master and several slaves are connected in I2 bus. USB is widely used protocol. Different version and a maximum of 127 peripherals can be connected to single host controller. USB acts as plug and play device. USB is used in keyboard, printer, mouse, cameras. It is designed for installation, faster data recorded, less cabling, etc. So serial communicate with peripheral, supply power to other devices. So CAN is used in 1980s by Robert Bosch. Previously late 1970s, advanced feature in automobile, anti-lock braking system, air condition, door, engine management system, etc. So can be used in the priorized ID, so highest can be interrupted. So ECU engine contain chip for receiving and transmitted information. So modification, inclusion of addition of data, stop and start of vehicle, etc. So in asynchronous, timing clock is common for both the devices. So it is a transistor logic. High voltage is logic 1 and low voltage is logic 0, and is used in most of the microcontroller. So Ethernet, already we know about Ethernet. So data communication connecting terminal or building geographical area. Ethernet token ring, wireless LAN are the example of standard LAN. And Ethernet will rule another packet collision. Ethernet use LAN technology and is used in IEEE as shown in figure. Ethernet are used to connect devices. Fast Ethernet, Gigabit Ethernet, 10 Gigabit Ethernet, Switch Ethernet. So advantages: speed, efficiency and quality. Disadvantage: distance limitation, bandwidth sharing, complexity, cable installation and physical. Which are the following is a serial communication port? Already we know what is that, all the above. What is the full form of universal asynchronous receiver transmitter?